Electric vehicles usually bring to mind brand new Teslas, Rivians, or factory-built electric SUVs. But another path to the electric future is gaining attention: converting older gasoline cars into fully electric vehicles. This video explores how gas-to-EV retrofits actually work, who is doing them, what they cost, how long they take, and the real-world trade-offs. It also highlights the companies and places leading this niche industry. It explains why, for the right vehicle and owner, an electric conversion can be both a technical adventure and a meaningful upgrade. Before we get started, please consider hitting the like button and subscribing to my channel before the end of this video. It only takes a second, and it really helps support my work. Thanks for watching and helping me get to 1,000 subscribers. Okay, let's get this going. Yes, it is absolutely possible to retrofit an older gasoline-powered vehicle into an EV, but it is rarely a simple bolt-on job. Instead, it is a custom engineering project that replaces the car's entire propulsion system. Light-duty vehicles such as sedans, hatchbacks, small trucks, and many classic cars are the most common candidates, mainly because they have enough physical space and simpler mechanical layouts. The process starts with removing the internal combustion engine, fuel tank, exhaust system, and related plumbing. In their place go an electric motor, a motor controller or inverter, a DC-DC converter to power low-voltage systems, an onboard charger, and a lithium-ion battery pack. The vehicle's wiring is largely redone, and the new electric drivetrain is integrated either with the original gearbox or with a single-speed reduction gear. Many modern kits are designed to fit within the existing transmission tunnel and mounting points, which helps simplify installation compared with fully custom fabrication. A small but growing group of specialist firms has turned EV conversions into a professional service, often focusing on classics or specific vehicle platforms. In California, EV West is one of the most recognized names in the field. The company offers turnkey conversions and also sells kits for vehicles such as the Volkswagen Beetle, Porsche 911, and various trucks. Also in the US, Fuel 2 Electric focuses on configurable kits and complete builds, with an emphasis on cost-effective systems. Zelectric, based in California as well, specializes in electrifying classic Volkswagens and early Porsches, often upgrading suspension, brakes, and lighting at the same time. At the higher end of the market, Zero Labs Automotive in the United States uses a modular ZLabs platform that allows certain classic trucks and SUVs to be electrified very quickly once in the shop. In the United Kingdom, Lunaz is known for fully restoring and electrifying classic luxury vehicles and coach-built cars, blending heritage with modern electric drivetrains. In Europe, BB Classic Cars in North Macedonia converts smaller European classics, such as the Fiat 600 and Zastava 750, into modest-range EVs. For do-it-yourself builders, parts suppliers, such as miromax.lt in Europe offer e-car conversion kits in the 3 to 20 kilowatt range, including motors, controllers, and accessories. Companies within the EV West and Fuel 2 Electric ecosystem also sell kits that bundle motors, controllers, chargers, battery management systems, and wiring harnesses. Costs vary dramatically depending on vehicle size, performance goals, battery capacity, and whether the work is done at home or by a professional shop. A typical conversion kit that includes the motor, controller, charger, battery management system, and wiring can range from roughly $7,000 to well over $25,000 for higher power systems. The battery pack is often the single most expensive component. Depending on capacity, chemistry, and packaging, lithium-ion packs can run from a few $1,000s for a small setup to $50,000 or more for large, long-range configurations. Professional labor adds another major layer, frequently ranging from several $1,000s to the tens of thousands, especially for classic or bespoke builds. Additional integration work for cooling systems, HVAC upgrades, power steering, and custom wiring can further raise the total. For a modest sedan or small truck converted by a professional shop, a realistic ballpark is often in the $20,000 to $40,000 range, not including the donor vehicle. Doing the work yourself can reduce labor costs, but it demands significant mechanical and electrical skill. Timeframes depend heavily on the build style and who is doing the work. A do-it-yourself project handled by a capable hobbyist can easily stretch across 8 to 12 months once parts sourcing, fabrication, and troubleshooting are included. Professional custom builds commonly take 3 to 6 months from teardown through final testing. Some modular or more standardized platforms, such as those used by Zero Labs Automotive, can reduce shop time dramatically once the vehicle is ready, with certain builds completed in a matter of weeks. The work typically moves through stages that include stripping and preparing the chassis, mounting the motor and battery systems, running high voltage and low voltage wiring, and finally calibrating software, regenerative braking, and safety systems. One major benefit is the operating cost. Electricity is usually cheaper per mile than gasoline, and electric drivetrains have fewer moving parts, which reduces routine maintenance. There is also an environmental argument. Reusing an existing vehicle body and many components can mean a lower embedded carbon footprint than scrapping a car and building a brand new one. Performance can be another pleasant surprise. Electric motors deliver instant torque, so many converted vehicles feel quicker off the line than their original gasoline versions. Perhaps most importantly for enthusiasts, conversions allow owners to preserve beloved classics, such as vintage Volkswagens, Porsches, or old trucks, while gaining modern drivability and emissions-free operation. The biggest hurdle is cost. For many vehicles, the conversion price can approach or exceed the market value of the car, which makes little sense purely from a financial standpoint. Range and packaging can also be limiting factors, because older vehicles were not designed to house large battery packs, sometimes leading to reduced cargo space or shorter driving range unless major structural changes are made. Regulatory and safety requirements add complexity as well. Depending on the region, converted vehicles may need inspections or certification related to safety and roadworthiness. Heating, air conditioning, and battery thermal management can require extra hardware, since many older cars lack robust HVAC systems designed for electric operation. Finally, resale value can be unpredictable, as converted cars often appeal to a niche audience, and insurance may be more complicated. Converting a gasoline car to electric is technically achievable and increasingly supported by specialist companies in places like California, the United Kingdom, and across Europe. It involves replacing the entire drivetrain, integrating modern electronics, and often re-engineering parts of the vehicle. The result can be a quieter, quicker, lower-maintenance car that keeps a classic body on the road with zero tailpipe emissions. However, the process is labor-intensive, expensive, and rarely justified on economic grounds alone. EV retrofits make the most sense for sentimental vehicles, rare platforms, or owners who value the blend of old design and new technology. For them, an electric conversion is not just a modification, it is a way of giving a familiar machine a second life in the electric age. Would you convert your vehicle to electric or just buy one? Leave me a comment on what you think, then check out some of my other videos. Don't forget to hit that like button and subscribe. Thanks again for watching until the end, and we'll see you at the next one. Take care, bye for now.